Hi, seventh graders. According to what you guys had said, we're going to do some markup and markdown review problems. If you look at example 1, it says, Harry manufactures t-shirts and sells them to a store in Metairie. Harry sells his shirts to the store for $4. Which I have here. Per shirt. If the store marks up the cost 80%, how much does the store charge per shirt? So I know the price that it's sold at to the store. So this is my original cost. And then the markup is 80%. What I want to do is part, percent, and whole. Remember that my whole is always my original cost. So my original cost is $4. Part is always my sales price. So the price that it will be in the store. And then my percent is my markup or markdown. If it's being marked up 80%, that means it's going up 80%. The original cost is 100% of the cost. And if it's being marked up 80%, we're paying 80% more than the original cost, or 100% of the cost plus 80%, which is 180%. We're going to pay 180% of the $4 when we buy the shirt in the store. So when I do percent, I'm going to write 180. And I just have to keep in my brain that I need to make this a decimal when I write my equation. My part, or the sales price, I don't know. It's asking me how much does the store charge per shirt. So I'm going to fill out my equation. My part should equal my percent, which I'll write as a decimal. Move it back 2 spots. 1.8 times 4. And this could be 1.80 times 4. It doesn't change. On this, we can use a calculator, so go ahead and Google calculator. X should equal 1.8 times 4, which is 7.2. I'm talking about money, so it's $7.20. There's our first one. That's an example of a markup. Our second problem is 2 steps. The second problem reads, Sarah buys a hat that has an original sales price of $15. So $15 is the original. The hat is discounted 20%. So 20%, and it's going down because it's a discount. Sarah must also pay a 6% sales tax. So it's going to go up 6%. But what's key here is it's going to be a 6% sales tax on the discounted hat. So we cannot do this until we know the discounted price. You simply can't say, well, going down 20 and up 6, that combines to 14. Absolutely not. We have to find the discount, and then we have to tax the discount. So part, percent, and whole. My original selling price is $15, and it's a 20% marked down, which means it's 20% off the original cost. I originally pay 100% of the cost, which is $15. If I pay 20% less, then I only pay 80% of the cost. So my percent is 80 because I took 20% off, and I don't know my part. My equation is part equals percent as a decimal times whole. 80% of $15 is $12. The hat is going to cost $12 when she gets 20% off. And this makes sense. I want it to be less than 15. So keep this in your mind, $12. Now, this $12 is what the sales tax is going to be for. So I'm going to erase this. She's now paying $12 for a hat. So this is my new original cost. This is a 2-part step, so if you want to draw a line, you can. It's going to take 2 steps. The 6% sales tax is an increase because when we pay tax, it makes our costs go up. It's going to make it go up just a little bit. So I'm going to do my part, percent, and whole. My cost that I'm taxing is $12. It's 6% sales tax of the discounted price. I don't know how much I'm going to pay then, but I know I'm going to pay 6% more than the original cost. The original cost is 100% plus the 6% sales tax means we're going to pay 106% of $12. I can write my equation. X equals, as a decimal, 1.06 times 12. This is with the sales tax. She will pay $12.72. And I just did that on my calculator. This is our final answer. It was $12 when discounted, but then once the tax was added, the price she'll pay at the register is $12.72. You have the next problem, and on the back side, you may have seen these problems before in benchmarks. It's a great review. They're all park practice questions. Good luck.